Hello guys, I welcome you to AB Mev Education. I don't know to say this is Mr. AB or Mrs. Sam. Right now I'm teaching in Dubai and they go by the first name, so they call me Sam. Also Mrs. Samuel here. We continue to look at this vertical and the horizontal shapes of a function, and I would like to use our Desmos to demonstrate more understanding. If today is your first time, please go ahead and subscribe and hit the notification bell, so anytime we drop a video, you will get notification of it. So first of all, let's go ahead and look at the parent. We'll be most of the time using the quadratic function, but it works for all absolute, linear, exponential, sine function, all of them will work for it. So this is a parent function, and if we're supposed to say do for x squared, what is happening is that we see that it's stretching towards the y-axis, and that is what we call the vertical function. So it kind of, if you have this string here, it's stretching vertically, and that's what is happening. So it's stretching vertically. So anytime this happens, we say it's stretch vertical. What about if it is the number is less than 1? So let's make it like a quarter. So if it is 0.25 x squared, okay, so we see that it's widening, it's moving away from the y. So now it's moving away from the y, and moving away from the y is what we call it compresses. So let's look at, say this is the function, and we have, say, kx squared. So we are saying that we are observing that when the k is bigger than 1, what is happening is that something is behaving towards the y-axis, which is a vertical, so it stretches vertically. And that's what we saw. But when the number is less than 1, realize that it's moving away from the y-axis, it compresses vertically. And that's what we call, so when the k is less than 1, it compresses, and that's vertically. Okay? Awesome. Now let's see what happened on the horizontal part of it. Remember, this is the parent function. Even if we want, we can use an absolute. So we can use an absolute. All functions behave the same. So this is absolute function. This is a parent function. The horizontal are going to be inside the absolute. So if we're supposed to, let's use an equal number. So if we're supposed to have 4, here what we are saying is that now it moves away from the x-axis, and moving away from the x-axis is what we call the compresses. So here it compresses horizontally, and then when we have less than 1, so let's pick our absolute, and then we got 0.25x. We see that it's going towards, it's stretching towards the x-axis. And we have seen this before when we were doing the translation. Realize that anytime it's inside the function, anytime it's inside the parenthesis, if it happens to be quadratic, if it happens to be the absolute, inside the absolute function, they behave a little opposite. And you can check that video out for you to get more understanding. So here, what we are saying is that when of say g of x, just f of x, g of x, h of x, y all means the same. It kind of just giving different names. That cannot repeat. It's like we have k's, you're going to give them different names for identification. So you can say that g of x, f of x, and all y is, they are all the same. It's just the names of a function. Okay, don't be confused with that. Here, let me use a different letter. Let me use h. So if we have h of x, inside the absolute, or you can say if you have this, because all functions behave the same. In the quadratic, what we are saying is that when the h is greater than 1, we see that it's moving away, and that was the middle number here, the black. It was moving away from the x, and that's the compressor. So they behave opposite to that of the vertical. So here, when it's greater than 1, we see that it compresses at this time around horizontally. Yeah? Now what we see is that when it's less than 1, this time around it stretches horizontally. So you have to take note of this. I'm showing you all these things so that you can see it visually. Sometimes it's really, really hard for you to see what is happening. So I'm using the decimals here to demonstrate more understanding. The same thing if you still want your quadratic. This is a parent, and as we did it, if it is inside, so 4x squared, you see that it compresses. We are using with respect. When it's inside, we are using it with respect to the horizontal, so it's moving away from the x-axis, so it compresses horizontal. When it's less than 1, it stretches towards the x-axis. You see, it's coming closer to the x-axis, so it elongates the x towards the x-axis. Okay, so moving forward, as we have already done a whole lot of stuff, we can model the equation. Let's use a quadratic, and here we can put h here, plus or minus, and now we can call this one, we can start introducing, say, a squared plus or minus b. So that's the general, this is the composition of all that we have been doing. Okay, and even let me put the negative also here so that we can get all the pieces together. So we are saying that when this negative here, it flips, it's just a reflection across x-axis. And this value here, that causes the vertical shift. And we have learned that when k is bigger than 1, it stretches, and that's a vertically. Okay, and when k is less than 1, it compresses vertically. This negative here, inside here, this is reflection across y-axis. This h here, that causes a horizontal shift. So here we can say that when h is greater than 1, it compresses. They behave opposite to that of the vertical. It compresses horizontally, and when it's less than 1, it stretches horizontally. When you get this, I mean, the stuff becomes so easy. And from our previous video, we said that when it's plus here, that is going to be a left shift, and when it's minus here, that's going to be the right shift. When it's plus here, that's the up, and when it's minus here, that's down shift. Yeah? So based upon this, you can do a whole lot of stuff. So in our next video on this transformation of a function, we will do more examples for you to see. Before we get there, let me give a quick example. So if you say you have h of x, as I said, h of s, g of s is just a name, and you have, say, 3, -3 absolute plus 2 minus say 7. You can see what is happening. 4 things is happening here. Reflection. So reflection is happening. So based upon the formula that I have given you, even if you haven't put it in decimals, you can able to see that what is happening is that there is a reflection across the x-axis. So reflection across x-axis is happening. Because 3, don't take this one to be -3 and say, oh, it's less than 1. No, just look at the number. So here, because of 3 is greater than 1, so this one is stretches vertically by the factor, because it's multiplying by the factor of 3. Yeah? And then here plus, so when it's plus, you can say that it shifts 2 units to the left. And then finally, this -7 here is, you can say it shifts 7 units down. And that is what is happening. You can graph it and you can see so easily. Always put the parent over there for you to see what is happening. Then we got -3, then the absolute x, and it was +2, and then -7. We can put this one down, and then we can see better. So we see, you compare this, you could see all that is happening. Always make sure you use a vertex, the tip, to see what is happening. So you can trace it and know that it dropped 7 down, and then it shifted to the left 2, and they have 10 around flipped. And here you see there is a kind of a little bit narrowing towards the y-axis, so that's the reason why it stretches. And that is what we have done today. So moving forward, we will look more example. Thank you for watching, sticking with me all the way to the end. Please go ahead and subscribe, and see you in the next video.